So, guys, we are here at the last day of our chapter, day 10, Pure Review. Friendly reminder that our exam is tomorrow. Tomorrow's Thursday. Hopefully, nobody's watching this past Wednesday. It's going to be from 8 to 12. Google Meets will not be required. I will have a Google Meet going in case you need to get in contact with me, but Google Meet will not be required. I will be on, though. Just want to let you know that I will be there if you need me. So, guys, because this is a review day, we're going to do things a little bit differently. I'm going to give you a chance to answer, and then we're going to check and see if you have done it correctly. We're going to do that for these. There's only going to be 7 problems here in our lesson. And after each one, we're going to get a chance to look over it, talk about it, work it out, see if you guys got this. So, and then we'll talk about what we're going to do with our multiple choice, which is going to be great practice. But let's start with number 1, guys. So go ahead. You can try number 1 for me. Let's see what you guys are going to do here. We're going to solve for x and for y in this system, if there is a solution. So go ahead. All right, so first thing I notice is x's and y's are not lined up. In fact, we have an x over here chilling by itself. And if you have a variable by itself, whatever it equals, you can plug in to itself in the other equation. So really, x is negative 3y plus 5. So 2 times negative 3y plus 5 plus 6y equals 10. And from there, you're distributing negative 6y plus 10 plus 6y equals 10. Combine like terms, negative 6y and 6y, those add out. They cancel out. You're just left with 10 equals 10. Was that a true statement? Yes, it is. Which means we have infinitely many solutions. These equations are really the same. If you were to divide this equation up top by 2, and then just move the y over, it would look exactly the same. So we have the same line. One line on top of another line. So if that had been 10 equals 6, we know that would have been false, which would have been a no solution. So how about number 2? Go ahead, guys, and try number 2 for me. All right, number 2. We see this middle line here is an angle bisector. It cuts these 2 angles in half. And because these 2 angles are the same, that means the sides they create are the same. So this side, OM, and this side, OP, are congruent. So if we want to find segment OP, and again, I always recommend boxing in whatever you need to find. That way you can keep track of what you're trying to solve for. If we're going to find this piece, we got to figure out what x is. So we know 6x is equal to 3x plus 12. I subtract 3x over. Divide by 3, we get x equals 4. We take that, plug that back in. 3 times 4 plus 12. That gives us 12 plus 12, which we know OP is going to be 24. And since we don't know the measure, we would say units. 24 units is what OP would be there, which means this, of course, also would be 24 units. All right. Next up, see what you guys can do with number 3. This time, this problem is very similar, except we're going to be working with angles instead of sides. So again, we know congruent angles here. We want to find angle Y, AYL. So we want to find this angle right here. Well, if these are the same angles, 7x plus 17 equals, a lot of weird parentheses going on here. We really don't need these parentheses. 3 times 4x minus 1 distributes 12x minus 3, subtract 7x over, add 3 over, you get 20, 17 plus 3 is 20, equals 5x Divide by 5, we get x equals 4. And of course, remember, we're not done. I boxed in this up here because I wanted to remind us. We're trying to find AYL. So you take this, you plug it in. 7 times 4 plus 17 is going to be angle AYL, which will equal, I believe, 45 degrees. 28 plus 17 will be 45 degrees. All right. Last problem on the page, guys. Anybody notice what kind of angles we got here? I hope so. I'm going to let you try number 4. Check this one out. We have an exterior angle, and then we don't have the angle on the opposite side, but instead we have 2 remote interior angles. And if you remember, an exterior angle is equal to the 2 remote interior angles added together. So we can say 5x plus 13 equals 4x plus 2. Here's this remote interior angle, plus 2x minus 9. When we combine our like terms, 5x plus 13 equals 6x minus 7. And I'll let you guys, of course, I'm sure if you got it right so far, you took this the rest of the way. Subtract 5x, and if I'm bringing the x over here, that means I need to bring the regular number to the left. So x is going to equal 20. And of course, remember, we were asked to find the measure of each angle. I forgot to box this in. I'll highlight it to make up for it. Find the measure of each angle. So we take 20, plug that back in. 5 times 20 is 100, plus 13. We know our exterior angle is 113. Which, of course, if this is a linear pair, makes this 67 degrees. So how about that, right? We got a linear pair here. This all has to add up to be 180. And remember, we also are going to plug 20 in, so 4 times 20 would be 80. And 80 plus 2 would give you 82 degrees here for this angle. And then finally, 2 times 20 is 40 minus 9 would give you 31 degrees here. Excellent work, guys. So let's jump to the last 3 here. The next 2, we got some good real-life application problems to see if these are testing using the triangle inequality theorem. And if you don't remember what that is, this is whenever any 2 angles of a triangle, this also applies, or I'm sorry, any two sides of a triangle must add to be bigger than the third. So any 2 sides of a triangle must add to be bigger than the third. So I'm going to let you guys see what you can do with that information. Now this is going to apply more to number 6. Going to apply more to number 6. This one right here is going to be a little bit different. It's going to be angle comparison. So I'm going to let you guys try number 5 first for me. Let's just focus on this one, and then we'll get to number 6 here shortly. So go ahead on number 5. Okay. So we're told we've got Bob, and Bob could see Rob. So we'll say Rob's right here. Bob can see Rob. Then he can turn at an angle of 80 degrees and see George. So if he turns 80 degrees from looking at Rob, he then turns, he can now see George. Okay. Rob could see George, then turn at an angle of 40 degrees and see Bob. So if Rob is looking at Bob, he can then turn 40 degrees and now be seeing George. I'm sorry, Rob could see George. So Rob's looking at George. Then he could turn in an angle of 40 degrees. He could turn this way and see Bob. Sorry, I got that backwards. Now, George could see Bob. So George is looking at Bob. Bob and Rob confuse me here. He's looking at Bob, then turn at an angle of 60 degrees, and now he's looking at Rob. Okay, so which two were furthest apart is now the question. Remember, the bigger the angle, the bigger the side it creates. And we know that angles are across from their sides. So 80 degrees goes to this side, 40 degrees goes to this side, and 60 degrees goes to that side. So clearly 80 degrees is our biggest angle. That means this side here is our biggest side. So we could say Rob and George were farthest apart. Rob and George were farthest apart here. Okay. Next to the last one, guys, number 6. Cole is training for a half marathon. This is going to involve the inequality theorem. And I'm going to go ahead and show you the answer to this one after you have tried it for me. So go ahead and try number 6. So check it out on number 6. He went 6 miles in one direction, ran 3 miles in another direction, and then 2 miles back toward his starting direction. Is it possible that when he stopped, he was back at his starting point? So in other words, is it possible we could create a triangle with these 3 sides? Well, we know that any 2 sides have to add to be bigger than the third. 6 plus 3 is 9, which is bigger than 2. 6 plus 2 is 8, which is bigger than 3. Ooh, but 2 plus 3 is 5, which is not bigger than 6. So no, these values could not create a triangle. Couldn't do it. I know some of us have kind of struggled with number 7. So really take your time on this one. Try number 7, and then we'll talk about these guys. Take a quick second. Try both of them. Okay. Now, hopefully none of you guys missed the fact that both these triangles and these problems are isosceles. That means that we know this side and this side, obviously not this side, since this is a right triangle. These 2 sides are going to be congruents. So, of course, FF is at the origin. We got some 0, 0 action there. But we also know that this is a height of a length of A. From 0, 0 up to here is a distance of A, which means if we go that way along the x-axis, it won't be 0A. If we're a point on the x-axis, it'll be A0. All right. Then our second triangle, once again, isosceles. We see here that this side and this side will be congruent. And the problem is we're not given much, but we are given that from here to here is A. And of course, if we're on the x-axis, we know it's going to be A0. Which means we know then that this is also going to be an equidistant here. From here to here will be the same. So that would be A as well, except this time we're going in the negative direction. So this will be negative A0. And then finally, we know up here, if we're on the y-axis, we know x is going to be 0. The problem is we don't know how tall this is from the bottom up to that, so we just are going to go with, let's call it B. All right, and so guys, with our test tomorrow, one final thing I just want to mention. This is going to be super, super important, especially early in the test. Classifying triangles by their sides and by their angles, guys. I cannot stress that enough. Classifying by sides, classifying by angles. You're going to be asked to do both, sometimes in the same problem. So a lot of times, the same problem is going to require you to classify by the side and classify by the angles. So you could have an acute equilateral. You could have, check this out. You could have an obtuse. None of these angles are the same. Obtuse scalene. See that? You could have, this will be a right triangle. We're not told anything about the sides, so you couldn't really make a claim about that. But you're going to sometimes be required to say both the angle and the sides. So keep that in mind, guys. And then, of course, just like we talked about on the first page, we know that if you've got one solution, you're going to get an answer for x and an answer for y. No solution will see us with parallel lines. You will get a statement that is false. We see that right here. None of those statements are true. And then, of course, if it's infinitely many solutions, we will get a statement that is always true. 0 equals 0, 1 equals 1, negative 4 equals negative 4. And so, guys, there are 24 practice multiple choice. And again, these are practice. Not going to post a Google form. These are all practice. And I'm actually going to put the answer key in a separate document included on Google Classroom. It's actually included in this exact assignment. So you can look for that, guys, if you need to see the answer key. And if you can do all 24 of these, you're going to be in great shape for our test tomorrow. So thank you guys very much, and happy studying.